Welcome. We want to look at the relationship between heat of solution, hydration, and lattice energy. But before we look at the relationship between these three, we need first to remember and understand some concepts that we learned in the topic of energy changes. That is the bond breaking and the bond formation. You need first to understand what is energy released during bond breaking or energy is absorbed. Is bond breaking exothermic or endothermic? Is bond formation endothermic or exothermic? That's the first concept I would want to remind you. The next one is the energy levels. How does the energy level of an exothermic reaction look like? How does the energy level of an endothermic reaction look like? A quick reminder is that in an endothermic reaction, the system absorbs heat energy from the surrounding. Therefore, the products have a higher energy compared to the reactants. Very important. So if the products have a higher energy, then we expect the reactants to be down, because suppose this one is 10, and then the products must be something 20. The energy is higher for the products. Remember that. So this one is for an endothermic. So always remember that for endothermic reaction, the products have higher energy and the reactants have lower energy. You know that, so it is a reminder, because this is what is important for you to understand the relationship between heat of solution, hydration, and lattice energy. In an exothermic reaction, heat is lost from the system. We know that. I know you know that. The products therefore have lower energy content compared to reactants. Are very important. So this one will help us to know the reaction, the overall reaction in exothermic is negative, because you see when the product minus this, it is 10 minus 20, the answer is going to be negative 10. Therefore, that's why in an exothermic reaction, the products are below the reactants. Let me repeat that. In an exothermic reaction, and you are drawing an energy level, the products must be below the reactants. The reactants should have higher energy content, and the product has lower energy content. That's another quick reminder. Next one, we want to remind ourselves about the bond breaking and the bond formation. So bond breaking and the bond formation involve energy changes in the substance involved. For example, when methane reacts with chlorine, like you can see in this equation, so for the reaction to occur, the covalent bonds in both methane and chlorine must be broken to obtain separate atoms. So for chlorine to react with methane, this bond in methane must break like this: hydrogen, 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 hydrogen. So this is bond breaking. Chlorine must break like this: chlorine, chlorine. So this is what we call bond breaking. So to obtain chlorine, for the reaction to occur, the covalent bonds in both methane and chlorine must be broken to obtain separate atoms. Energy is required to break these bonds. Thus, bond breaking is an endothermic process. Please mark that. Bond breaking is an endothermic process. Once the bonds are broken, the atoms rearrange themselves and new bonds are formed. And the new bonds are formed in the products. Very correct. In the process of bond formation, energy is given out. Therefore, bond formation is an exothermic process. Very, very, very critical for you to understand that. So what we were reminding ourselves is that bond breaking is an endothermic process. Bond formation is an exothermic process. Very important. back to our business of the day, relationship between heat of solution, hydration, and lattice energy. So let us define what is lattice energy. Lattice energy is the energy change that occurs when 1 mole of an ionic compound is formed from its constituent ions in gaseous form. Now this is an ionic bond plus another ion here. This is an ion plus another ion forming sodium chloride. So this is an ion and this is an ion. They are combining to form sodium chloride. So is it bond breaking or bond formation? This one is bond formation. We have said that bond formation is an exothermic. Therefore, lattice energy involves bond forming because the cations here in gaseous form, they are combining to form sodium chloride, and that's why the lattice energy here is negative, because bond formation is exothermic. Therefore, the overall heat change is negative. So it is important to know what is lattice energy. It is the energy change that occurs when 1 mole of an ionic compound is formed from its constituent ions in a gaseous state. Lattice energy is negative, but has a negative value because the reaction is exothermic. Lattice energy is denoted by this. So we denote lattice energy by this heat change, lat. So lattice energy of sodium is -77 kilojoules per mole. So when sodium chloride is formed from the ion, from its constituent ions which are in gaseous form or state, then -776 kilojoules the heat is released. So 776 heat is released. To release, it is exothermic. Now this is where our concern is. Now we have formed sodium chloride, which is an ionic compound. So we want now to add water to sodium chloride. So that's where our concern is, dissolving sodium chloride in water. So when an ionic substance dissolves in water, energy equivalent to the lattice energy is absorbed. For example, when sodium chloride is dissolved in water, the ionic solid dissolves in 2 stages. So it doesn't just dissolve. When sodium chloride is dissolved in water, it dissolves in 2 stages. Stage 1, the solid sodium chloride is separated into its gaseous ions, meaning that sodium chloride is broken down. That is bond break. The bonds are broken like this. So sodium chloride breaks like this, gaseous plus chlorine ion, which is gaseous. So the solid sodium chloride is separated into its gaseous ion. So the bonds are broken. That's why it was important for you to remember bond breaking. So if bonds are broken, is that process endothermic or exothermic? So bond breaking is endothermic, right? So the process is endothermic because we are breaking the bonds. Sodium chloride is breaking to form sodium ions, so the bonds are broken. Therefore, the process is endothermic. So the amount of energy absorbed is equal to lattice energy, but has a positive sign, right? The positive sign, now remember lattice energy has a negative sign because it is bond formation. But now dissolving sodium chloride in water, it is bond breaking. The bonds are broken, therefore it is the opposite. It is the reverse of lattice. Therefore the reaction is endothermic. The amount of energy absorbed is equal to lattice energy, but has a positive sign. The lattice energy is given a positive value because bond breaking is an endothermic process. Very, very important. This is called the reverse of lattice energy. Remember, lattice energy, it was the ions in gaseous form forming sodium chloride. So when you go this way, you form bonds of sodium chloride, you form, and the lattice energy is negative. But now sodium chloride is dissolved in water. It breaks fast. It is separated to its ions in gaseous. So sodium ion in gaseous form, chloride ions in gaseous form. So this reaction, this process is endothermic, and that's why the heat change is, or the enthalpy change is positive 776. But you realize that this reaction, it is the opposite of the lattice, because lattice is negative and reverse lattice is positive. The energy is the same. Very important. So the bonds are broken, and then the heat that is absorbed is 776 kilojoules per mole. So that is stage 1. What happens in stage 2? Stage 2. In this stage, the sodium and the chloride ions, now the one after bond breaking, we have the sodium and the chloride ions, which are in gaseous form, get surrounded by several water molecules. The water molecules surrounding the sodium ions arrange themselves in such a way that the partially negative oxygen is attracted to the positive sodium ion, and the partially positive hydrogen is attracted to the negative chloride ions, and the ions become hydrated. Now we are now talking about the second term, hydration. So now these ions, the sodium ions, which are in gaseous form, and the chloride ions, which are in gaseous form, are surrounded with water molecules, and they become hydrated. So they are surrounded in such a way that the sodium ion, which is positively charged, arranges itself such a way it is attracted to the oxygen, which is partially negative. Remember, oxygen is negative and the sodium is positive, so these charges, they attract to one another. So you can see it is the oxygen, sodium, oxygen, sodium. The chloride ion is surrounded by the partially positive hydrogen. So hydrogen is positive and the chloride ion is negatively charged. Therefore, the water surrounds the sodium ions in such that in this way, and then the ions becomes hydrated. So when something becomes hydrated, if you jump into a swimming pool, you go deep into the water, you are covered by water, you become hydrated. So these ions now covered by water, they become hydrated. So now we have talked about the hydrated, the second term, hydration. The hydration process is exothermic. Hydration process is exothermic. When the gaseous ions of sodium and chloride are immersed now in water, are now attracted to the molecules of water, the reaction is exothermic. The energy released is called hydration energy, and it is denoted by delta H, hyd. So now the sodium ions in gaseous form, the chloride ion in gaseous form become immersed in water, and they become surrounded by several water molecules, and they become hydrated. So once they become hydrated, they change to aqueous, because now water they dissolve, forming an aqueous solution, and now the ions become aqueous. So the enthalpy change of hydration is -771 for sodium chloride. When sodium chloride dissolves in water, the enthalpy of hydration is -777 because hydration process is exothermic. Therefore, hydration energy is the energy that occurs when 1 mole of a gaseous ions become hydrated. Now we have done 2 terms. The third one is heat of solution. Now what is heat of solution? This is the overall enthalpy change that occurs when 1 mole of a solute is dissolved in water. It is denoted by delta H solution, SLN. So heat of solution, it is the overall enthalpy change that occurs when 1 mole of a solute is dissolved in water. It is denoted by delta H SLN. That is heat of solution. Now the next one we want to look at now, what is the relations between the 3 of them? Now we are looking at the relationship between now the heat of solution, hydration, and lattice energy. Now since we are dissolving an ionic compound in water, we have already dissolved that. To form a solution, we are forming a solution in aqueous state. That is the final product. We add reverse lattice energy. Reverse lattice energy, remember, it is bond breaking. Which is a positive, and hydration energy, which is negative. Therefore, the relationship between the 3 is that heat of solution is equal to lattice energy plus hydration energy. But always remember, hydration energy is negative, the reaction is exothermic, and the lattice energy used here, which is the bond breaking, is endothermic, positive, negative. Go to lattice energy, enthalpy of lattice energy plus hydration. Now for sodium chloride, you saw we say that the reverse lattice is positive 776 and the hydration is negative 771. So we just add here enthalpy change of lattice is 776 plus minus positive times negative is negative. So it is 776 minus 771, which will give us positive 5 kilojoules per mole. So what that means is that the overall reaction is endothermic. The overall reaction is endothermic because the overall reaction during this solution formation, we are getting a positive number, meaning that the overall reaction is endothermic. Now this value here will help us to draw the energy level diagram and even the energy cycle. Now this is the energy cycle diagram for sodium chloride. When sodium chloride is dissolved in water, this is the energy the energy cycle diagram that is obtained. So remember, this is sodium, which is solid. When it is added to water, lattice energy, because we said when sodium is dissolved in water, it undergoes 2 stages. The first stage, the bonds are broken, forming the ions in gaseous form, and that's what we call reverse lattice energy, and we assume it is lattice energy, but we know it is reverse. But what makes the difference is the negative or the positive. So both cases, whether it is in negative or positive, both are called lattice. But what tells somebody that you mean lattice for exothermic or lattice for endothermic is the sign, whether it is positive or negative. But we know this is bond breaking, therefore it is positive. Now sodium ions in gaseous form is added, water is added, and they form aqueous, and this is the final product, and this process is called hydration, or the energy here is hydration energy. Sodium adding water to sodium, we form sodium ions in aqueous, chloride ions in aqueous, and that's what we call heat of solution. So if I want now to calculate heat of solution, because this is the direct route, you remember the Hess law. This is indirect route and this is the direct route. So if I want heat of solution equal to lattice energy plus hydration energy. So from the energy cycle diagram, heat of solution equal to lattice energy plus hydration energy, like this. We knew this one, so this one is 776, we know that, and this one is negative 771. So we add, heat of solution is equal to this plus this. So we add and we get this. So we can use the energy cycle to calculate the heat of solution also. The next thing we want to draw to see how it is drawn is the energy level diagram. Energy level diagram for this reaction. Energy level diagram for dissolving sodium chloride. Now this is the energy level diagram, the one I started with to tell you that you should know. Energy level diagram depends on whether the reaction is exothermic or endothermic. But we know that the dissolving sodium chloride in water, the overall reaction is positive. In actually positive 5, the one we have done. Although this one I'm using a different values, so don't worry. But the overall here is positive 7. So let me use the one which is here, positive 7. Heat of solution, the overall heat change for solution formation is positive 7. So the final product formed, because we are dissolving sodium chloride in water, we are forming the final product here, which is in aqueous state, AQ. It must be in aqueous state. So this process, we said, it undergoes two stages. Stage 1, sodium chloride is broken. So you see from here, we go up. The arrows are very important. The sodium chloride is broken. The bond breaking process to form sodium ions in gaseous form plus chloride ion in gaseous form. Yes. Now the water, remember these ones, they are in water. Now stage 2. Stage 2, these gaseous ions interact with water molecules forming aqueous. But now that's why now after adding in water we get in aqueous state. And this one is what we call hydration. This one is called hydration. Enthalpy of hydration energy, right? Now from here, sodium chloride plus water, the direct route is heat of solution, which is positive 7. Now what I am interested here is to see where the products are, because the reaction is endothermic. The final enthalpy change is positive, so you must ensure that the products are higher than the reactants, because we know in an endothermic reaction the products have higher energy than the reactants. These are the reactants. Dissolving sodium chloride in water, these are the reactants forming the product, aqueous, right? So that's why you must ensure that the arrow goes up to the products, endothermic. This one indicates the reaction is endothermic. The overall reaction is endothermic. The overall. Now I want to show you the energy level diagram for exothermic and endothermic overall reactions. If the overall reaction, after calculating the heat of solution, you have calculated the heat of solution, the heat change of solution, and your overall answer is positive, that reaction is endothermic. The overall reaction is endothermic. So how are you supposed to draw your energy level diagram? These are reactants. For example, I've used an example of sodium chloride plus water. These are the reactants, and the final products are higher than the energy of the final product is higher than the energy of the reactants. The energy of the final products is higher than this. So therefore, the heat of solution should be, the arrow should go upwards. If the overall heat of solution, or the value, is negative, like here I have given an example of negative, overall reaction has negative 80 kilojoules per mole. So this is how the energy level diagram will look like. You will draw the x and the y axis and make sure the reactants start higher. These are the reactants: sodium bromide plus water. This is plus water here. So we are forming, and this is the heat of solution, H3. This is the enthalpy change of solution. Yes, we are going up. This is lattice energy, because the sodium bromide is being broken to sodium plus bromine, right? Sodium ions plus bromide ions, which must be in gaseous and not in aqueous, in gaseous. Then when we add water, now we come straight down, right? We come straight down. So to form sodium ion in aqueous and bromide ion in aqueous, the overall reaction should be exothermic. So why? You can check that from here. The reactants are higher and the products are low. They have low energy. Reactants have higher energy in an exothermic reaction, and the products have lower energy content. The products have lower energy content and the reactants have higher energy content. So we use this, suppose here it is 10, this one is 20. You can see the products have a lower energy content, so that is exothermic. So whenever you are drawing an exothermic energy level involving the heat of solution, this is how it should appear. I will do more examples. I will give more examples so that you can understand better. The hydration energy of sodium chloride is the sum of the separate hydration energies of sodium ions and chloride ions. In an exam, you realize that you are given the hydration energy of chloride ions alone and the hydration energy of sodium ions alone. So what are you supposed to do to get the total? You add them. So you add, for example, this one is negative 390 kilojoules per mole, and this one is negative 384 kilojoules per mole. So what you do to get the enthalpy of hydration, the hydration energy of sodium chloride, what you do, you add the two. That is negative 390 plus, but it is a negative 384, and then you find that the total heat of hydration or energy of hydration is negative 4 kilojoules per mole. 4 kilojoules per mole. Now let us look at some sample questions, examples, so that we can it can help us to understand more what we have talked about. The diagram below shows energy changes that occur when sodium chloride dissolves in water. A reaction bath, and this is the energy level diagram. Question A. So you need to study the energy level diagram. So we have sodium chloride plus water. So we are having this arrow going up, and we have sodium ions, chloride ions, and then we are adding water to come down. Then here we have the overall, the products which are in aqueous state. That is the products. Those are the products. Now let us go to question. What does H1, H2, H3 represent? So let us go back. H1, sodium, the bonds are broken into gaseous form. Which energy start? That one is lattice energy. Lattice energy. Lattice energy, or you can call it reverse lattice energy if you want. H2, the gaseous ions are in water, so that is hydration. So H2 is hydration energy. Hydration energy. H3, sodium chloride, is reacting with water directly, forming sodium aqueous directly. This is the direct route. So sodium aqueous, therefore this is heat of solution. Heat of solution. Which of the three delta H1, delta H2, delta H3 have positive values? Positive values. We know sodium bond breaking. This is lattice energy, which is positive. So H1 is positive. Hydration is negative, and this one is going up. It is positive. So H3, H1 are a positive. So H1, delta H1 and delta H3 are both positive. What does the negative value of enthalpy change mean? Negative value means that the reaction is what? Exothermic. The reaction is exothermic. The negative value for enthalpy change means that the reaction is exothermic. Given that the lattice energy of sodium is 776 kilojoules per mole, and hydration energies of sodium ion and chloride ion is -407 and -364 kilojoules respectively, calculate the heat of solution of sodium, or heat of solution of 1 mole of sodium chloride. Very good. So we are answering the solution. We know that the hydration energy, this one is refusing to fit, hydration energy is the sum of the energies of sodium ions and chloride ions, equal to sodium ion, the energies of sodium ions, which are gaseous, plus chloride ions, gaseous. So the sodium ions, we have been told, this -407 plus into -364. So the final answer is -771 kilojoules per mole. But we know that heat of solution, because we are asked to calculate the heat of solution. So heat of solution, we know that heat of solution, change enthalpy in heat of solution, equal to enthalpy change of lattice plus enthalpy change of hydration, height. We have lattice, we have been given that the lattice energy of sodium is 776, so that one is direct, 776 plus into -771, and the final answer is +5 kilojoules per mole. So if you are asked to draw the energy level diagram, you will draw. The overall reaction is exothermic, you will be able to draw. So let me sketch for you how you will draw that. Suppose you are asked to draw the energy level diagram. Energy level diagram. So I want just to sketch. Remember, it is sodium. So sodium, and the overall is endothermic. Are you seeing? Therefore, we start our reaction down here to make sure that the products will be higher. And then we know sodium chloride will dissolve in water, right? And then it will first stage, the bonds in the sodium chloride will be broken to form sodium ions in gaseous plus chloride ion in gaseous, right? And then remember these ions are still in water, yes. And then we have hydration, the enthalpy of hydration. Now the overall we have it is positive, therefore heat of solution must be upwards, and this way we are going hydration, we are going now to form sodium positive in aqueous, chloride plus chloride ion in aqueous. And you write that the reaction bath energy, you write energy. So by doing that, you know this one is enthalpy of lat, hydration, and this one is enthalpy of solution. In this case we have it is positive 5 kilojoules per mole. Hydration we have it is negative 771. Lattice we have it is 776. And this is the energy level diagram for this. Another example, the lattice energy of sodium bromide and hydration energy are 733 kilojoules and negative 741 kilojoules respectively. A. Calculate the heat of solution of sodium bromide, of solid sodium bromide. Right? So the answer is simple. We know that enthalpy change of solution equal to enthalpy change of lat plus enthalpy change of hyd. Remember, hydration energy is always exothermic, negative. Lattice energy is bond breaking, which is positive. So we have this, which is 733 plus into minus 741. Our answer is going to be 733 minus 741, and the overall is negative 8 kilojoules per mole. Now the overall reaction is exothermic, and we know how an exothermic energy levels looks like. So let us, the next question B is that draw the energy level diagram for the dissolving of sodium bromide. So this is very important. It is going to help us to know, we have already now known that the overall dissolving of sodium bromide in water, the overall energy change is negative 8. So the reaction is exothermic. The overall reaction is exothermic. So let us see now how you are going to draw the energy level diagram. So draw your y-axis. I've drawn my y-axis. Let me draw my x-axis. There is this. Since the final reaction is exothermic, our reactants must start in the middle here. Our reactants must start in the middle here, right? So our reactant is sodium bromide added to water. Remember, that is the reaction, because we are dissolving ionic compound in water. That is the concern. That is what we are doing. So what will happen? Stage 1, the sodium bromide will break, the bonds will be broken, forming sodium ions in gaseous form and bromide ions in gaseous form. So that one is endothermic and it has to go up. So this one will go up. This one will form sodium ion in gaseous form plus a bromide ion in gaseous form. But this one, these ions are still in water, therefore plus water. Right? So if they are still in water, what do they form? They form a solution in aqueous state. Sodium bromide plus water. What are you forming? You are now immersing these ions in water and you are forming a solution. Therefore, heat of solution must come down. Therefore, even if before we bring it down, we can draw this one. You can draw this one. So sodium bromide plus water, we form a solution. This one, so we are going to form sodium ions aqueous. That is the final product, plus bromide ions aqueous. So sodium ions in gaseous form plus bromide ions in gaseous form plus water, what did they form? They directly form, this one is in aqueous, right? So that's why this one arrow comes like this. Now we have this one, but we from the equation we have hydration energy. Hydration energy is from here up to here, which is -741 kilojoules per mole. We have lattice energy. Lattice energy is the energy of breaking the bond to form a sodium ion in gaseous form. So that one is lattice, which is 733. So we can calculate now this heat of solution. Heat of solution we can calculate using this one. And this is how, so you write this one, a reaction, but here make sure you write energy. And this is now the energy level diagram for dissolving sodium bromide in water. Have you seen the difference between endothermic and exothermic? Now this is how exothermic looks like. But now we have the heat of solution, which was -8 kilojoules per mole. The following information, use the following information to answer the questions below. Enthalpy change lattice of magnesium chloride, lat is -2489 kilojoules per mole. Hydration energy for magnesium 2 positive is -1891. Hydration energy of chloride ions is -384 kilojoules per mole. The question is, calculate the heat of solution of magnesium chloride. Draw an energy level diagram of the dissolving of magnesium chloride. Is the dissolving of magnesium chloride an exothermic or an endothermic process? Give a reason for your answer. So this is the final question I want us to answer, and by doing this, I think you must have seen how these things are done. So the lattice of magnesium chloride is -this. So first let us calculate the total hydration energy. So magnesium 2 positive alone has -1891 kilojoules per mole. Chloride ion, one chloride ion is -384 kilojoules per mole. But remember, magnesium chloride is written magnesium chloride. So the chlorides are two of them. And this is the enthalpy change, or the enthalpy of hydration of one chloride ion. Therefore, we multiply here times 2 to get the total. This one will be 8, 16, 7, -768. So for us to get the total, the hydration energy for magnesium chloride, we add this and this. That is -1891 plus -768. We get the total for hydration. So using your calculator, this one will give us -2659 kilojoules per mole. So that is the hydration energy. But we know heat of solution we know that heat of solution, enthalpy change of heat of solution equal to lattice lat plus enthalpy change of hydration. So look at this one. We were given that the enthalpy change of lattice of magnesium chloride is negative 2489. So we are dissolving magnesium chloride in water. So this negative has no effect here because the reaction of breaking magnesium chloride into magnesium ions in gaseous form and the chloride ions in gaseous form is endothermic because we are breaking, and if it is endothermic, this value must be positive. So this negative sign should not scare you. So you assume that it is not there, because dissolving magnesium chloride in water, the first stage we have said, magnesium breaks, magnesium chloride, the bonds are broken, and the bond breaking is endothermic. Therefore, this value is positive. So now this one will give us, use your calculator, 2489 minus 2659. This one is bigger, therefore the answer is negative 170 kilojoules per mole. So what this means is that the overall reaction dissolving magnesium chloride in water, the overall reaction is exothermic. The overall reaction is exothermic because you can see then the overall answer is negative. Hydration solution energy is negative. So the next question was, draw an energy level diagram for dissolving magnesium chloride. So we want now to draw the energy. Now this value is important. It's going to help us to draw the energy level diagram. So let us go, take your ruler and let us draw that. So first, draw your y-axis, draw your x-axis, draw your x-axis. We know the overall is exothermic. Therefore, you should know that our product must be down here. Our product must be down here, which must be in aqueous state. That one you should know. So, and you should know that our reactants must be in between here. Our reactants must be between here, somewhere here. Our reactant must be somewhere here. So let us begin with the reactants. What are our reactants? It's magnesium chloride dissolved in water. Right? So the first stage, because it's an endothermic, it has to go up. Breaking of magnesium chloride to form magnesium ions and chloride ions, the reaction is endothermic and it has to go up. Very good. It must go upwards. So once you have that arrow, draw as a very straight line here, like this. Don't worry about anything. So here, magnesium, remember this one is a solid. So magnesium, 2 ions which must be in gaseous form, because this is magnesium chloride being broken. The bonds are broken to form 2 chloride ions which must be in gaseous form. But remember this, so magnesium chloride is in water, so plus water. Right? Now, magnesium ions in gaseous form, chloride ions in gaseous form are surrounded by water molecules. What do they form? They form, straight down, they form magnesium ions, they form magnesium 2 ions in aqueous, plus chloride ions, 2 of them in aqueous, and that's our final product, right? And then we bring this. So magnesium chloride dissolving in water downwards, it is a dissolving, that is heat of solution, which is coming down, and this one is enthalpy heat of solution. This one is enthalpy energy change over Lat, bond breaking. And this one, now the ions are immersed in water, they become hydrated, and once they become hydrated, they form aqueous solution. An aqueous solution is formed. So we write the solution in ionic form, which are in aqueous. And this one is enthalpy change of hydration. Right? Now we have this one is negative 2659, negative 2659 kilojoules per mole. We have enthalpy change of solution, the one we have calculated here, heat of solution is negative 170 kilojoules per mole. We have lattice energy, we were told it is negative 2489, but since this one is reverse, that is bond breaking, it should be positive, so it is 2489 kilojoules per mole. So reaction bath energy. Because the overall reaction is exothermic, you must ensure that the products have lower energy than the reactants. These are the reactants. Magnesium chloride plus water is what is reacting, what is dissolved to form aqueous solution. The process can be taken in two steps. It can either go to form aqueous, to form gaseous form, and then come to aqueous, or it can go directly to form this. Using Hess laws, now we can draw energy a cycle for this. Let me draw you a small energy cycle for that. So this one is magnesium. We have finished the energy level. Now I'm showing you how to draw energy cycle for the same magnesium chloride solid. So this one will form magnesium 2 positive gaseous plus 2 chloride ion gaseous. When this one water is added, add water. So when this one water is added, add water, we form magnesium 2 positive aqueous plus chloride ions, 2 of them aqueous. And this is a simple energy level diagram. What energy change is this? What energy change is this? From solid bond breaking. So this is lattice, reverse lattice. So that is enthalpy lat. Magnesium ions in gaseous form, water is added, that is hydration. Hide. Magnesium is dissolved in water directly to form magnesium solution, aqueous. Therefore, what is that? Enthalpy of solution. And this is the simple energy cycle we have drawn. We can use this one also to get the value we have. We have this one is negative 2659. We have this one is negative 2489. This one hydration is negative 2659, negative 2659. So you write here negative 2659. So hydration energy is equal to this plus this, and you are done. But hydration here should not be negative, it should be positive because this is bond breaking. The final question I want to answer is this one. The final question I want to answer is the dissolving of magnesium chloride an exothermic or endothermic process? Give reason for your answer. So that is the final thing I want to answer, and I want to answer it like this. The answer is the reaction is exothermic. What is the explanation? The reaction, it occurs with release of heat energy. How did I know this? We have the final overall reaction to be negative 170, therefore the reaction is exothermic. I want to thank you. I don't know whether I have helped you solve your problem in understanding this, but I hope I have done. Thank you very much. We put here 2A248.9, which is lattice, plus into hydration negative 26.59.